Okay, this is problem 871 in the calculus-based physics book. This is a conservation of momentum problem. So what we have is a 8-kilogram block of wood sitting on the edge of a frictionless table. So let's draw that. So here's the table. Here's the edge of the table. Here's the floor. And there is a block sitting right on the edge. And it's originally stationary. The mass of the block, I'll say the mass of the big B for block is 8 kilograms. The height above the ground is 2.2 meters. And it says a 0.5 kilogram blob of clay hits the block. So the mass of the block, small b, the mass of the blob is 0.500 kilograms. So what will happen is we have this thing hit the blob, it'll become one unit, and so we have an inelastic collision. And then you'll have a final velocity from the collision, and that final velocity will be the initial velocity for this thing to go out and have parabolic motion. So the first thing, we got two parts. We've got the collision part, and then we've got the projectile part. So for the collision part, we use conservation of momentum, which says the mass of the blob times the initial velocity of the blob plus the mass of the block times the initial velocity of the block is equal to the mass of the blob plus the mass of the block, both times the final velocity. So since they stick together, we just use one final velocity. The initial velocity of the block is 0. And so if we solve for the final velocity of both of them, you'll get the mass of the blob times the initial velocity of the blob divided by the sum of the two masses. So final velocity of, I guess that's the final velocity of both of them, so we don't need an extra subscript, is equal to the mass of the blob, which is 0.500 kilograms, times the velocity of the blob, which is 24 meters per second, divided by the sum of the two masses. So we got the 0.5 kilogram blob and the 8 kilogram block. So we have 0.5 times 24 divided by 0.5 plus 8. And that comes out to be 1.41 meters per second. Okay, so that's the final velocity of the blob on the block after it sticks to it. Now, this second part is the projectile motion. So in the projectile motion we have, let's use V0 because that's kind of what we use. So we've got V0 x and V0 y. So because it's on a level table, there is not going to be any initial y velocity, and the x velocity is 1.41 meters per second. We have delta y is equal to negative 2.2 meters, I think. 2.2 meters. And the acceleration in the y direction is negative 9.8 meters per second squared. So just like the test for projectile motion, we do the y direction first. And what we're going to do is we're going to solve for the final velocity in the y direction using this equation. So the initial velocity in the y direction is 0. So we get, therefore we get the velocity in the y direction is plus or minus the square root of 2a delta y. Now it's going to be minus because it's falling down. So we get 2a negative 9.8 meters per second squared times delta y negative 2.20 meters. So that's going to be 2 times 9.8, 2 times 9.8 times 2.2, take the square root of that, and we get negative 6.57 meters per second. And then we can use the equation v sub y is equal to v0y plus a t to solve for t. Again, the initial y velocity is 0. So you get t is equal to v sub y divided by a. And v sub y is negative 6.57 meters per second divided by negative 9.8 meters per second squared. That gives time 6.57 divided by 9.8. And you get 0.670 seconds. And then in the x direction, you use that time in the x direction. So delta x is equal to v0x times t. And because there's no acceleration in the x direction, this is constant. So we take our velocity, our x velocity, which we got from the first part of the problem, and we multiply by the time. And you can see meters per second times seconds. You get seconds cancel out, so you get meters. And I get delta x equals 0.945 meters. So that's how far it goes. And let me make sure I answered all the questions. Clay, the combined object leaves and travels forward horizontal distance. Okay, so I got the answer. And I'm pretty sure that's right. But I don't want to record this if it's not correct, so let me try this. 871. Oh, I'm going to go to the end of the book. 8.71, 0.946 meters. Okay, so we're done.